Welcome back. It's been a while, and I've finally got one of these water heater controllers from Poland. I've been wanting to get one for a long time, often even thought about buying one myself. And so I'm going to be doing a couple videos about how they work and what's good about them, what's bad about them. As you can see, it's just you hook up to a solar panel. You have a photo booster. That photo booster is just 3 capacitors in parallel. They're 100 microfarads each, and they're 400 volts. You got a little protect diode here for reverse voltage so you don't damage. And they fit in this little cabinet. And you can see the total that was measured was 273 microfarads and 78 milliohms. So that means each one of these is about 180 milliohms each. Pretty high. And of course this design, basically I tell people that it's a European design where the water heaters are much lower wattage, much higher resistance. With this small capacitance, you really want to have a very high water heater resistance. Not really suitable for the US market because most people are running between 100 and 150 volts on panels, and they're using 5,000 watt elements or at least 3,500. And of course that makes the time constant much shorter, and it doesn't work as well. So right here we can see this is the on period, and this is the off period, so the capacitors are recharging. Now this looks pretty good, but this is with this extra capacitor in parallel. This is 1,000 microfarads, so already this is 3 times more than this. So in total, when this is switched in, it's 4 times more capacitance. So let me switch out that capacitor, and you'll see this big ramp up. So there's a big voltage drop, and that's because this one is 970 microfarads and it's 40 milliohms internal resistance. But more importantly, there's a lot more capacitance to store power in the off periods. So going back, you'll see how that flattens out a lot more. This is the AC waveform on the capacitor. And as you can see, it's charging up, discharging, charging up. So the more capacitance you have, the better it'll work. So this is the unit right here. And I started out at 17 degrees C. I had this little water heater. It's 2.5 gallons. This is 8.5 ohms for a load, which gets you about 4.2 amps peak. So 4.2 is way under the 10 amp specification of this. You'll hear the fan turn on now and then. So let's go to menu. At NN1, you can see here, this is the voltage. So these are 200 watt panels, so you only got 200 watts max. We got a few clouds today, and we're not going to get a lot of power. I mean, maximum is 200 watts. So NN2, here's the wattage, and that has significantly dropped. It was about 100 before. Well, let me show you what happens. There's the wattage. You can see it's around 50. You take that capacitor out, and you can see the power drops. So it's worthwhile adding an extra capacitor. From what I've seen so far with this, everything, it doesn't bother the operation of the microprocessor having the extra capacitance. This thing is an ACTii Omega microprocessor inside, and they're using the PWM, and the PWM is at 180 hertz, if you're wondering. And I thought this would be more than double that. I thought with the small capacitance they'd be operating at a higher time cycle.